Assalamualaikum and very good morning. Today, my team will present our integrated design project with title Cadangan Membina dan Menyiapkan Pangsa Puri di atas bahagian lot 3311 daerah Pasir Putih, Kelantan.
My name is Siti Aisha binti Azman. This is my team members. Nur Azrin binti Harun, Nur Hanis Elisa binti Hamidun, Nurul Hafiza binti Saiman, Serina binti Muhammad Asri.
Firstly, introduction about company background and project information. Our company name is Ash Engineering Consulting Sendian Berhad. Next, company background. This company is a Bumiputra firm of consultancy services for civil engineering works and project management, which established on 3rd September 2017. Our company provides an expert in civil and structural engineering design such as railway bridges, marine work, infrastructure, road and drainage, design, reservoir, treatment plant and telecommunication tower. This is our organizational chart. Serina binti Muhammad Asri as Managing Director, Nur Azrin binti Harun as Infrastructural Design Engineer, Nur Hanis Elisa binti Hamidun as Structural Design Engineer, Nurul Hafizah binti Salman as Structural Design Engineer, and lastly me, Siti Aisha binti Azman as Project Engineer. Project information. This project is 4-story building of apartment located at Pasir Putih, Kelantan, Darul Naim. Building apartment consists of 4 floors, which is ground floor, first floor, second floor, and third floor.
Firstly, we will start with structural design analysis. The following are structural elemental design that are included in this project, which are beam, slab, column, shear wall, foundation, staircase, and retaining wall. I am Nohanis Elisa binti Hamidun and I will explain about the chosen structural design, which is column. The chosen column is C69. From this plan view, the chosen column, which is C69, can be clearly seen. It is located at one of the corners in the building. Moving on to load distribution. In this 3D drawing designed by Esteem Software, the load from the roof is distributed through the column at the floors below until it reaches the foundation. Each of the floors has its own dead and imposed load as displayed. Therefore, the total dead load determined on the foundation is 389.53 kN, while for imposed load is 33.25 kN. Next, we will proceed with the column reinforcement design. First and foremost, the basic information of the column is the size, which is 300 x 400 mm. Then, we check for the slenderness, lambda. The top and bottom end condition is considered as condition 1. Therefore, the coefficient is taken as 0.75. Thus, from the ground floor to the first floor, the effective length is 2475 mm. We continued with checking for lambda. Lambda has been determined as 21.41, while lambda limit is 128.15. As the value of lambda is less than lambda limit, the column is considered as short column.
I am Nur Hafiza binti Saiman and I will continue this presentation. I will explain about detailing reinforcement of the column. In detailing reinforcement, firstly, we need to find the area of steel bar required. In order to do that, the bending moment applied to the column must be determined and the value obtained is 5.07 kN. Effective depth calculated is 1.23 mm, which gives a value of D over H equal to 0.85. The design chart of D over H equal to 0.85 for rectangular column based on Eurocode 2 is referred to determine the value of ASFYK over BHFCK. The value obtained, which is 0.035, is based on the moment and load applied to the column. This value will also be used in designing required steel bar area. The required steel bar area, as required, is then calculated, which is 280 mm square. We proceeded with calculating the minimum steel bar area, as min, which is 240 millimeters square. This value is obtained by taking 0.2% from the column area, which is 300 millimeter by 400 millimeter. While for maximum steel bar area at S max, it is obtained by taking 4% from the column area. Based on our calculation, the value of AS required lies between AS minimum and AS maximum. Hence, this column design is passed. We decided to use 6T12 with area 678 mm square for the main reinforcement bar. Next, we need to find the size of ink and the spacing for the steel bars. Here are the drawing details for the chosen column C69. The reinforcement bar is designed to be 3 at the top as well as at the bottom, and the length is R6 225 mm center to center. The last part for column design is the calculation comparison between manual and esteem software. It is being done in terms of design load, moment, and AS required. The manual calculation is considered acceptable. As we can see, the difference is less than 10%. That's all for column design.
Okay, now we are going to look for the infrastructure part. For infrastructure, we have earthwork, drainage, sewerage, and also water articulation. For this slide, we are going to focus more into sewerage. For the design, we refer to the Malaysian Sewerage Industry Guideline (MSIG) and the Malaysian Standard of the Code Practice. As what you can see on this plan view, we have proposed a system to ease the flow of sewerage from building into the existing manhole, where waste from the building will travel through underground and passing through this manhole and finally reach through the existing manhole. Next, for the design of pipe, we suggest to use 225 mm as the pipe diameter. As what you can see on these longitudinal cross sections of the sewerage, the invert level descends gradually along the system. This is to enable the gravity to take place in allowing the waste to flow through the pipe. So here is the sectional area of manhole based on the API precast catalog. As we know, there are limits when designing with the flow velocity of the waste. According to the design guideline, it must be within 0.8 to 4 meter per second. Therefore, gradient slope plays a big role in maintaining the velocity. Hence, there are several checks that need to be done, and one of it is velocity check. As what we can see in the table of this slide, the pipe velocity are all within the pass range that has been set in the guideline. Apart from that, we have to do pipe flow checking, where the pipe flow should be greater than the peak flow capacity, as in our case of design or the pipe pass. Hence, it can be said that the overall design of our sewerage system is acceptable according to the design aspect. Now, I will hand over the slide to Serena.
Hi, my name is Serena binti Muhammad Sri. So for my part, I'm going to present the project management for our project. So taking off refer to the process of identifying elements of construction work that can be measured and priced. So taking off consists of the calculations of formwork, link concrete for ground and below elements, concrete work, reinforcement of main bar, and also link for every element that is required of reinforcement. So the example of taking off that we have done is including beam, slab, column, foundation, and also wall. So this is the summarization of taking off done for one building that consists of 4 floors. Okay, next. After the taking off is done, we need to come out with the total price of the project. So these are the type of costs that need to be taken in consideration. That is direct cost, indirect cost, fixed cost, variable cost, and also sunk cost. So lastly, this is the cost of work for the whole project. As we can see, building work took almost one third of the project cost because of many work need to be done in the construction of the building itself. So that's all from me and my group. Thank you.